This time will be the lecture 18, right? So I will continue to talk about programming with Grid Free. Last time we finished here, right? We show a demo for how to program a P2P framework. This is a P2P based instant chatting, instant messaging system. I show you code, how to program this code, and how to show this demo, and two clients. But this client is create a chatting client. Like call it, it's better to call it the chatting client, or chatting users can use this client and to chat with each other instantly. Only network latency between such chatting. So this performance is much better, and then the MNCS. MNCS is based on the client server architecture of the framework. So we have to send a polling message to the server to get instant message. So it's delayed some time based on the polling periods, length of periods of polling. So it's not it's must some delay when the user chatting with each other. So because based on the P2P architecture, so this system is much better based on the chatting. If the chatting perform between two clients within a Wi-Fi or LAN, within a LAN network, that's fine. However, if the two clients or two user is out of the LAN, I don't think it's good enough because the users there is maybe some users usually when we chat each other in practice in the market, all the chatting system actually is still based on MSS rather than P2P architecture. That is the primary reason is because of security issue. Security issue. So it's not proper for an unknown user to access you smartphone, you desktop, laptop, because if it's possible for any user to access your system through CD message, it's possible to some malicious behaviors are included in such access. It's possible some the security issues are raised in such a scenario. So usually we do not do that. So usually for security consideration, all the messaging instance messaging system based on MSS. Okay, this time we will talk about another framework implemented with the peer API and the peer design pattern. Okay, this is I will talk about N-tier framework. N-tier means this system is divided, split into multiple tiers. Each tier is focused on one specific application. So this is usually this typical architecture for the enterprise system. Some popular enterprise systems use such a framework to perform distributed application. So, for example, the famous N-tier architecture is three-tier architecture. I'm not sure whether you know about that. This is the typical architecture for web-based application. In such application, the browser is a client. The browser is a traditional client. It's a typical client implemented with for example, the primitives, grid free primitives of the CS client, or the synchronous eventer, remote eventer, the asynchronous remote eventer, or remote reader. This is the client. In Browser is just is a typical client, right? And another one is the middle tier. The middle tier is application server. The business logic is located in such a server. So all the user interaction, user interact with the application server through send a message and exchange message between the browser and the application server or web server. Web server, for example, Tomcat, right, is a typical web server. And Spring Boot, someone must know about this one, Spring or Spring Boot. This is the typical application server. So user can access that server to perform the business logic, right? So the business can be the e-commerce system, a banking system, financing system, and most of the online application based on the 3-tier architecture. So application server is a middle tier. The database is the usually we call it back-end tier. Back-end tier. The frontier is the browser. I just mentioned. The middle tier is the application server or web server. We also have the back-end tier, right? Usually it's a database, some distributed database, some other NoSQL database. The data should be persistent. A data storage system. All the data that should be persistent usually is implemented on the back-end tier. So 3-tier architecture is very typical. It's a typical architecture for web-based system. It's very popular. If in some more complex system, maybe the number of tier is larger than 3. So for in general, NT architecture is can be we need to implement NT architecture. We need to know how to implement such NT architecture or 3-tier architecture with some techniques. I think grid free is if using grid free, it's easy to implement such a framework. So this time, I will show you how to implement such a framework with grid free. Because we have no sufficient time for each class, so this time we are just at the beginning of this class. So this time we talk about a simplest 3-tier system, and in such a framework, each tier only contain only one distributed node, the client, and the peer, and the server. Each tier only one particular computer devices is used. But I think in practice, there are a lot of such. Each tier must contain a lot of numbers computer devices. Each tier must be at least the middle tier, right? Middle tier that must be a cluster, and the back-end tier must be a cluster. A lot of computers are organized together as a virtualized server, as a virtualized peer. But in the later classes, we'll talk about how to implement such tier. But for this class, we just show how to implement a very simple one, the simplest 3-tier framework. Okay, and all the programming components we used in this class are DP and peer, the new API we implement in the previous classes. Okay, let us take a look at the code first, and then I will show you how to run such a system. Okay. Okay, let us open Eclipse. Eclipse. Okay. Okay, it's here. Should be here. And open this window. Last time I finished here. Okay, so I need to close all the windows. Let us open the corresponding projects. It should be N tier. Let me check. N tier. You can find such projects according to the name as what we have done before. Yes, here. Can you see it? The three projects. The first one, front. Front means frontier. I just mentioned here, right? Front means frontier. Okay, you can see here. The name is front. 3-tier. CPS. What is CPS? CPS is stands for client, tier, and server. Yeah, this is CPS. CPS, client, peer, server, right? This okay. So you can understand. You can the name. When name this, you can find the project according to the namespace. And I hope I can. I'm trying to write a book on these techniques, so I will give you a detailed introduction about the code. So right now, I'm still working on this project. So you have to sometime maybe you might get some trouble when you to find the sample code, but it is not so difficult. Okay. This is a front. Okay, front message terminal. And what else? There's still, we need to find the middle tier. Okay, let us, if you have, the middle tier should be, we can find the middle tier in this way. For example, coordinator request, search. Coordinator, right? Coordinator is here, it's here, right? Okay, this is another way to find the project you want. For example, here, if you know the message, this message, you can search the reference in Eclipse, and all the projects that referenced this message will be listed here. So that's another way you can find a project in Eclipse if the project is large, right? You can find this package through this way. Okay, so this is the from. Another one is a term coordinator. What is coordinator? Coordinator is just like it is a middle tier. The client, this client, the front tier will send the message to the coordinator. Then coordinator will forward this message with incoming message to the backend tier. And after that, the backend tier processes this message or retrieve some data from the backend tier and then return the message to the coordinator. And after getting this notification or get responses from the terminator from the backend tier, and the coordinator can generate a response for the client. So that is a typical interaction between the three tiers. So coordinator is identical to the concept of middle tier. This is another name I used. Okay, the terminal is a server. Terminal is identical to the server. Terminal. In grade 3, terminal is identical to the concept to server or CS server. Why we call it a terminal? The terminal means the dead end. We cannot move forward anymore. This is a terminal station. For example, when we arrive, when you take the bus or take the subway, and there must be a terminal station. You have to get off at the terminal station because there's no way to move forward again anymore. So that such a station or such a node, distributed node, I call it a terminal. For a CS server, for a typical server, after receive any messages, after incoming message I receive, the server it's impossible for such a server to forward this message to any other ones. Such a server have to process such incoming messages by itself. There's no way for it to forward such a message to other nodes. That's completely different from peer, right? Peer is able to forward, so the incoming messages can be like passengers, right? Like passengers can be move forward continually. If a passenger arrive one intermediate station, the messenger can continue to move forward. If any message arrive appear, then this message can be forwarded continually, right? There's some other distributed nodes can process such an incoming message. So that means peer is not a terminal, but it's an intermediate station. However, the CS server is not. CS server is a terminal. So in such a system, in such a 3-tier architecture, the terminal should be at the back end. The terminal should be the server should is a primary programming component at the back end. However, the kernel of the middle tier should be a peer, right? Because it needs forward the message. The client can only send the message. It's the same as the typical client we implemented before. So the updates, the changes for such a system, different from the typical client server system. Such a system is scalable as well. In this case, in such a sense, the CPI system or 3-tier or N-tier system is scalable. Right? Is scalable. However, the CS system, the client server system is not scalable because the server is not is a terminal. The server cannot send any message, cannot forward. Okay, so let us take a look at such an implementation of the system. Okay, let us take a look at this implementation. We can start from the frontier. Okay, here we open this plan. There's no any difference when we implement such a client. There's no any difference from what we have done before. You can see here. Let us open this code. This is a singleton, and then what else? remote reader, right? Remote reader initialized here, and then a request is sent from the client to the middle tier. The middle tier is implemented with the peer. Okay, next, let us continue here. Okay, eventer. For this case, we just use the simplest one. The simplest eventer is called sync remote eventer. So only synchronous message notification is sent from client to the middle tier. So you must be familiar with the code, right? The pattern is very simple. Okay, this is the client. I think it's very easy. It's not difficult to be understood. Okay, so let us move forward. Here, this is the middle tier coordinator. You can see here, this is the starting point, right? Starting point. There's no difference from what I have seen before. So you must have seen such code structure a lot of times. Open this one. Coordinator, peer, right? Peer. This is it's better for us to make some comparison here. Let us open the P2P architecture. Here should be P2P, right? We see such code before. Chat peer, right? Okay. Identical design pattern are used, right? No any design patterns are implemented during the procedure. No any new design patterns are created. Although we have a new API, it's called peer. However, the code structure is identical. The design pattern for peer is a straightforward aggregation for the client and the server. The code structure is same. Okay, we need to initialize. First, we need to stop, implement the stop. That's the same, right? Exactly same. Okay, what about this? Star. Initialize the peer. A lot of parameters need to be set. And the starter peer here. Next. What about this? Why there's no such pod request they send to the Redis server? Why? Because for such a system, there is a parameter here, right? I'm not sure whether you have noticed this difference here. For this case, for the chatting application based on P2P architecture, the peer has the attribute is registry needed. So this one, the parameter is true. However, for this one, the parameter is false. That means when this peer for the simplest 3-tier framework, this peer is not registered to the Redis server. However, for this one is for this peer, the peer is registered on the Redis server. Why? Because this is the simplest N-tier architecture or 3-tier architecture framework. So only unique peer is available. So when the computing resources in one particular system are limited, a very limited number of computer resources are existed in one particular system. it's not necessary for us to perform registry. I'm not sure whether you understood or not. I think for the TNCS, MSS, in such a two example, only one computing resources in terms of a computer, a server exists. So in such a system, no registry is required, right? So for our system, for this system, although it's different from MSS and different from the client server based system, however, the computer resources is still limited. Actually, usually, this attribute in most time in practice usually it should be true, but for some simple cases, it doesn't matter. You can set it to be false. Okay, that's the reason, because the computer resources is too limited. So we can perform some we can use some hard coding skills to program. You can see here, if the client want to access the server, the IP address is hard coding here. Hard coding, right? Can you see it? Hard coding. This is hard coding. The IP address is hard coded. And here, this IP address is also hard coded. So the client does not need to access the address server to get such IP address of the peer. And even for the back-end system, we will see the terminal, we'll see it later, all the IP address is also hard-coded. So no register server, in such a simple cases, no register server is required. So here, no registry is needed. I remove the code. For simple cases, it makes sense, right? Okay. In this one, in the server, we need to shut down such a. If we need to shut down the coordinator, we just send a message to this server. So start a server. Okay. We had two additional methods. This method works in the way of a client, because the peer is not only a server but also client. So this piece of code performs some action the same as the client. It's terminal address. Do you see the terminal address? The terminal address. This is hard coding, because the system is simple. So each distributed node, no matter whether it's a client, a peer, or a server, because only 3 distributed nodes exist in such a system. So all the IP address can be hard coded. For simple cases, it's fine. For complicated cases, register server should be created. So first, it can send a notification, and then it can also send request and get a response from the terminal. Okay, so it's easy to implement. The code structure is exactly same as this one. If you program a peer, just the message is different. Right? Just only message is different. Okay, let us take a look at dispatcher here. There's no difference. There should no difference in terms of code structure or design pattern. Okay, let us take a look at open this one. The same, right? This from notification is sent from the client, right? Sent from the client. And this one from request is sent from here. From request. Okay. What else? What else? Then initialization, the notification dispatcher, request dispatcher, close them. And what else? Now we need to process them through the switch case statements. Exactly the same, right? Next. Let us open this thread. It's a notification queue, so we need just to follow this same structure. You can see a coordinator. This coordinate notify method is invoked here. So after the front notification is received from the client, and then the coordinator can send this notification to the terminal, right? To the terminal, because this method we just review right here, right? So it's easy, and that's the same thing, right? No difference. We can take a look at this one. Any notification is processed in the same way. Okay, what about this one? Is thread. Okay, the front request is received, and then we need to invoke this method. This method sends such request, keep sending such a request or forward such a request to the terminal, and waiting for the responses from the terminal. After this response is received, and the terminal, the middle tier, the coordinator can invoke this method respond. Then the new responses based on the response from the terminal can be sent to the client to fulfill the requirements, the query of the client. Maybe the database is accessed, the query is processed at the back end, because the back end usually we persist a lot of data. It's a database system. So database system process such a query and then generate this response. So the coordinator can respond to the client. Okay, so this one is actually it's easy. This one, these 3 lines can be, the 4 lines can be regarded as a procedure to process the incoming message. It's application level code. That's the same as what I have done before, but although the code a little bit complicated. For this case, for the chatting application, the only one line is implemented here because the application is simple. They just display the chatting message on the screen. That's enough. However, for here, this upper level application code is difficult because one additional forwarding or request is needed. So the interaction between the coordinator and the terminal should be performed, and then the response can be created. After that, the responding method can be invoked. Although the code is a little bit difficult, but the code structure, the design pattern is the same. Okay, I think it's easy to understand coordinator. I finish here. Okay, next, let us take a look at the terminal. Okay, we start from here. Okay, here. This is a terminal. Terminal is exactly the same as what we have seen. For example, here, this is the MNCS multi-node, right? Multi-node. Because it's just exactly implemented based on the CS server, so the code is exactly the same. Okay, the only difference here is the exception is implemented here. For this case, implementation is through. It doesn't matter. For the simple case, it's fine. Okay, let us open this one. Okay, two instance of the CS server is implemented. Yeah, I think another thing I need to mention is here we have two server dispatcher, right? I think it's better for us to, for example, this is the coordinator. We just introduce this dispatcher, but however, about this one, this is also a server dispatcher. Let us click. This is so when the message is received, the coordinator should be shut down, right? Okay, let us open this one. Stop. Okay, everything is the same. So okay. Next, let us continue talking about the terminal. The terminal here, two instance. That's the same, right? Two instance. This is a chatting server for MNCS. Okay. So some of the application code here. For this case, the application is very simple. So it's just show the distribute programming. So the upper level application is very simple. So I do not implement anything here. This is the application code. However, no application code for this case. So I will only create two instances of the CS server. Okay, then start them. That's the same thing. Okay, next. The most important code is server dispatcher. Yes, we can see here the notification. Because all the messages sent to the server have to be processed by the server only. The server impossible for the server to perform any forwarding actions. So the code should be exactly we have seen before. Let us make a comparison here. This is notification, right? This is notification. We can see here, this one is the thread to process incoming notification. So for this case, the message is saved in the chatting session. However, for this case, after notification is received, the terminal just displays the message on its screen because no any response is required for notification. So it just displays the message. This one is a very simple application, so nothing is performed here. However, for this case, if the coordinator request is received, then it display first display, and then it generate a response. It requires to generate response, and then it sent to the middle tier, the coordinator. That's it. Also the same thing, right? After the chat registry request is received, a new account created, and then the response is generated. This application code is simple, But the same thing that's the same. We need to generate response. That's the same thing. Okay. Under that, we need to send the response to the middle tier. Okay. Generate response. Send the response. Okay, this code is exactly the same. And okay, I think it's that's enough. We have explained the same code structure many times, so it's easy for you. It should be easy for you to understand that. So next, we need to run such a system, because as this, I'm not sure, because I need to run this system only in a single computer. The IP address, I'm not sure whether it's set correctly or not. So if some problem happens, that only because the IP address, but I think it should be correct. I already run it. I teach in the universities, so it should be fine. If some problems happens, it only because the IP address issue. Okay, let us take a look at this one. Wind primitives CPS, right? CPS is okay. Let us do something here. Coordinator. Although there is a Regis server, you can see there Regis server. Actually, is that I do not use it. For this case, it's not useful. Okay. Coordinator, because it's the middle tier, right? Coordinator is here, and then this is the terminal. This is terminal, right? And for this terminal, okay, when primitives, CPIs, then from, okay. So usually we start from here. This is middle tier. Coordinator is started. And then we start the terminal. Okay. This is the sales server. This is the peer. Okay. What else? The client. Okay, notify the client. It is a simple menu here. The client will send a notification to the middle tier, and the middle tier must receive this message. Something will display on the screen, and the server or the terminal must also receive such a message, because it's forwarded by the middle tier, by the coordinator, right? Let us do the first experiment. Okay, very successful. Okay, notification, I'm learning cloud programming. Okay, and then you can see the same thing is received from the server, right? The server received such a message, the middle tier received it, and the back end tier also received such a message. Query. Okay, it seems a little bit slow. That's because of lazy initialization problem. We can do that again. It's fast, right? Because for the first time, initialization is slow because the thread, some computer resources are not ready to process incoming message. So the first one, with a notification, we can keep sending request. Okay, everything is fine. So when we see the query, a response will be generated, and then some information is received. The terminal server says cloud programming is a technique to implement the TARF system. Okay, that's a request. That's a response actually generated by the response, generated by the terminal, and then terminal receive such the coordinator receives such a response and then send to the client. Okay, the demo is successful. So we can close such a system and then, oh, sorry, I'm not sure whether I implement, it's fine, that's fine, doesn't matter. I want the main is empty. I think I must delay it some time, so it doesn't matter. So I think it's easy for you to understand. You can implement such code later. Okay, so I do not. The code is implemented. I do not want to waste time on that because it's easy. We have shown a lot of demos, some demos in the previous classes. So, but I need to mention it's not good for us to close in this way, right? We need to implement a system, a client administrator to send the information to the server to close such system safely, right? In a safe way. This is not good way to close a distributed system. Okay, that's because this system is simple. Okay, I'm not sure why the code is removed. It doesn't matter. Okay, we already talked about such a implementation a lot, so you should be able to do that yourself. Okay, in the next time, I will create some application online. I will create two systems. The first one is based on the P2P architecture or framework. In such a system, I will create a simple file transmission application. So when the client, two peer will reuse the distributed framework, P2P distributed framework. In such a framework, a file such as a picture will be loaded from the disk at one peer, and then such a picture will send to another peer remotely. And then after the message is received, the picture, the data in such a message, data in such a message will be persistent, will be saved on the disk of another client. Okay, another peer, another distributed node. This is the first implementation, first code application I will create it in the next class. After that, another one is I will show how to program with a 3-tier framework. I will create, I will extend the simple e-commerce system. You must have remember that, right? Remember the code here. When the show, not this one, right? You must remember this one, right? We create a TNCS system. In such a system, this is a very simple e-commerce system, but in this system based on the TNCS architecture, only two distributed nodes, one client, another server, and the two messages are processed. The first one place order, the next one is merchandise request the response. So for this time, I will extend such a system. So three nodes are included. The first one is the client, the middle tier is the peer, and the back end tier is the server. The server is just can be regarded as a database tier. Okay, I will create another application. Two applications will be programmed online. Okay, that's all for today. Thank you so much. See you next time.